Hello friends, MoNaCo here. We're still in our first unit of study, doing a supplemental video today on significant figures and estimation in measurement. So you're going to need page 17 in your packet. We're talking about how to make accurate measurements using our measurement tools, most specifically rulers and graduated cylinders, which is related to our first lab of the year. So got to know how to estimate these last digits. We call significant figures a method for handling uncertainty in all measurements. This arises and happens because we have different equipment with different abilities to measure accuracy. So there's some rules about adding, subtracting, multiplying, and dividing significant figures together that we're not really going to go into. The important part here is dealing with the certainty of the measurement. Anytime you make a measurement, you are recording digits that are significant, that are important. Okay? That's why we call them significant figures. So any measurement you ever make is completely significant figures. You just have to know how to estimate the last digit. Because, for example, reading this little ruler, we see that whatever object we've got, it's this long. Okay? Right there. We know for sure that this object is more than 2 centimeters, but less than 3. You see that it's somewhere in between 2 and 3. Now, because of the increments on this ruler, the little tinier lines, we know that there's 10 between 2 and 3, which means each one is a 0.1. And so we count. We see 2.1, 2.2, 3.5, 2.6, 2.7, 2.8. Oh, but it's more than 2.8. But it's less than 2.9. So here's where the estimation comes into play. We know this measurement is bigger than 2.8, but less than 2.9. So it's up to you, the measurer, to estimate the length. In this case, I'm guessing the last digit is a 3. You might guess that it's a 1. Mr. Milks might guess that it's a 9. The point is, this last digit is our estimated digit, and you have to put it in your measurement. So when you're using a ruler this year, I want to see 2 decimal places all year long, because all our rulers have millimeters on them. And we can go to the 10th of a centimeter, a millimeter. Now, graduated cylinders, we always read from the bottom of the meniscus. You do not read your measurement from the edge where it touches the number. You read it from the middle, right here at the bottom, kind of the lowest point. Those tools are designed to make the measurements at that point. That's why we have to read the meniscus. In this scenario, the volume reading that I'm getting is 27.5, because I can see on my cylinder that it's greater than 25, it's greater than 26, it's greater than 27, but it's not quite 28. So I picked my estimated digit to be halfway between 27 and 28. Graduated cylinders are a little tough in our lab this year. The 100 mil graduated cylinders, each line means 1 milliliter, so you'd go to the 0.1. 1 decimal place. The 10 mil graduated cylinders, each line, actually, they have smaller increments on them, so you're going to get 2 decimal places in a 10 mil graduated cylinder reading. So that covers the content of estimating the last digit. If you don't understand it at this point, there's a really good way to learn it with this method called the Atlantic Pacific Pacific method. It's a tried and true method to help you remember significant figures and their rules. Thanks for watching.